Welcome to the Octavia Lab. This video is the first in our Octavia Lab Projects series. Once a month, lab staff will be producing videos that show you how to create some of the works that have been featured in the lab. There will also be a companion series, Octavia Lab at Home, which focuses on projects that you can do from home. For the inaugural episode of Octavia Lab Projects, we're going to be creating a set of custom coasters. Let's get started. Before starting our project, we have some considerations to make. I've decided to use Cork for the coasters in this project, and I've decided to use the laser cutter for etching my design. Working with Cork has some benefits and some drawbacks. Cork is relatively inexpensive. Etching designs into Cork yields consistently high contrast results that you can't achieve with other materials. However, Cork does not lend itself well to cutting some custom shapes. I want to have a standard round-shaped coaster that is still functional. So this means no custom cuts, because I don't want any condensation to leak through. To save myself some time, I've purchased some round coasters online. Using round coasters on a laser cutter presents us with a small problem: alignment. I can place the coaster in the top left corner of the laser cutter's plate, but I will have two relatively thin points of contact to try and square off my measurements for my final design. In order to resolve this problem, I've decided to create a jig. This jig will hold the coaster in place, but more importantly, it will provide a much larger area of contact with the edges of the laser cutter's plate. More contact makes for more accurate measurements, which should make for a more pleasing final result. Rather than purchase and wait for the delivery of birch or cast acrylic to laser cut the jig, I've decided to 3D print it. I'll create my jig based on the coaster manufacturer's measurements. The coasters are 3.5 inches in diameter and are 0.2 of an inch thick. The jig I create will be square-shaped. It will be 4 inches long and 4 inches wide. This will give me at least half an inch of bleed area for my design. I'll make the jig 0.2 of an inch thick as well so that it's flush with my coaster. This will make it easier to see my design being etched in the laser cutter and reduce the amount of filament used by the 3D printer. To create the jig, we're going to use Tinkercad. Tinkercad is a free, easy-to-use online 3D modeling web app that is owned and run by Autodesk. To use Tinkercad, we have to register an account. This will require a valid email address. Once we've created our account, we're ready to begin. First, we'll click on the blue Create New Design button to open up the modeler. Tinkercad's work plane uses millimeters as its default unit of measurement. Rather than do any conversions, we're going to change the unit of measurement to inches. To do this, we're going to go to the bottom right corner of the screen and click on Edit Grid. In the Grid Properties window, we're going to go to the Units drop-down and select Inches. Then we're going to click on Update Grid. Now that our units of measurement are correct, we can begin modeling our jig. We'll start by selecting a box from the Shapes menu in the right-hand column. With the box selected, we're going to click on the work plane to create our starting box. Once the box shows up on the work plane, we're going to click on the white indicator above our box and enter in 0.2. This is the desired thickness of our object. We are then going to click on the white indicator to the right of our box. From here, we will enter the width and length of our object, which is 4 for both. With our box completed, we now have to cut a hole in it to accommodate our coaster. To do this, we select the cylinder hole from the Shapes menu in the right-hand column. The cylinder hole is identified by its alternating gray stripes. With the cylinder hole selected, we're going to click on our box to create a new cylinder hole. Once the hole shows up on the work plane, we're going to click on the white indicator to the right of our box. We will then enter the diameter of our cylinder, which is 3.5 for both length and width. Once our diameter is correct, we will go to the Shape menu and bring the number of sides of our cylinder up to the maximum of 64 to ensure the roundest cylinder possible. Next, we're going to place the cylinder as close to the center of the box as possible. Then, we will select all of the objects on our work plane by holding down Ctrl-A for Windows or Command-A for Macs on our keyboard. Then, we will select the alignment tool from the top menu bar. Then we'll press the black dots on the bottom and left of our objects to align the center of their X and Y axes. Then, we'll click on an empty work plane space to deselect all objects. Then we click on the cylinder hole. With the cylinder selected, we will click on the black cone above it and drag down slightly. We do this to make sure that the hole penetrates the box completely. With that done, we're going to use the cylinder to punch a hole through the box. To do that, we're going to select both items, and then click on the Group button from the top menu bar. Next, we will name our design by clicking on the placeholder text at the top of the screen. Now that our model is complete, we can click on the Tinkercad logo in the top left corner of the window to return to our 3D Designs folder. In our 3D Designs folder, we can click on the model we created and it will allow us to download it in STL format. In order to 3D print our coaster jig, we must first run it through MakerBot Print. MakerBot Print is the software we use to prepare models for printing on the lab's Replicator Plus printers. Once we have opened MakerBot Print, we need to import our model. To do that, we click on the Project Panel button in the top left corner. Then we click on the Add Models button. In the open window, select the coaster jig file. The software should place the model in the center of the plate. There is a settings adjustment that we need to make before we slice our file. To change settings, click on the gear icon in the toolbar on the right side of the screen. Then, click on the Custom Settings button. Go to Extruder Settings and increase the extruder temperature to 220 degrees. Then click Done in the bottom right of the window. Next, we need to slice our file. To do that, we click on the Estimates and Print Preview button in the toolbar on the right side of the screen. Once the software has completed slicing the file, it will tell you how long it will take to print the object and how much filament it will require. Now that the model has been sliced, we can export our file for printing. To do this, we click on the red Export button in the bottom right-hand corner of the screen. Now we're going to create the design for our custom coasters using Adobe Illustrator. To set up our file in Illustrator, we're going to click on the Create New button. Then we're going to click on the Print option at the top of the New Document window. We are going to change our unit of measure by clicking on points and dragging the menu down to select inches. Next, we're going to change the width and height of our document to be 4 inches each. In the Advanced options, we're going to change our color mode to RGB. Then, click on the blue Create button in the bottom right corner of the window. With our document created, we're going to go ahead and turn on rulers to help lay out our design. Next, we're going to create a guide to show us where our coaster fits in our document. To do this, we click on the Ellipse tool, which is the circular button in the toolbar on the left-hand side of the screen. With the Ellipse tool selected, click anywhere on the screen. In the Ellipse dialog window, enter 3.5 inches for the width and height. Then click OK. Now we need to center our circle. To do this, go to the Align menu on the right-hand side of the screen and click on Align Horizontal Center, and then Vertical Align Center. To turn our circle into a guide, go to the View menu, select Guides, and then Make Guides. Now that our guides are set up, we can go about creating the design we want on our coaster. You can create a design using any of the tools available within Illustrator, or you can import an image. For our example, I'm going to open a design that we've already created, and then copy and paste that design into our file. If you zoom in and move the file around, you'll see a light blue border that represents the size of our coaster. Everything inside of this blue border will be etched onto our coaster. Now we need to eliminate any of the design elements outside of the blue border. To do this, we're going to use a clipping mask. We're going to create an ellipse just as we did when we created our guide before. Once our ellipse is the correct size and is centered, we're going to use the Selection tool to select all of our objects. Once all of our objects are selected, go to the Object menu and select Clipping Mask, and then Make. To send our design to the laser cutter software, we go to the File menu and click Print. In the Print window, under Options, check to make sure that the placement has the top left box checked. Then press Print. To open up VLS, the laser cutter software, click on the small red box icon in the taskbar. Now that the design is set, we're going to set up the equipment. Open the lid to the laser cutter and place the jig on the top left corner of the plate. Now we must enter our settings for the laser cutter. To do this, we click on the red Settings button in the bottom right-hand corner. In the Settings window, click on the Find button and then type in Cork for your material. Click Search. When you find an appropriate material, click Select. Now we go to the material thickness setting in the bottom left corner of the window and input our material's thickness, which is 0.2 of an inch. Once you've entered the correct digits, press Enter and then click the red Apply button. Before we begin our laser etching, we need to get an estimate for how long it will take. To do this, we click on the red button with the 3 zeros. We then click on the red Start button directly below it. This will tell us how long it will take for the laser cutter to complete the etching. Now that the software is all set, we need to turn on the air filtration system as seen here. Once the air filter is on, we can start our etching. To do this, just click on the big green play button.